Hello everyone and welcome back again. Today we'll start looking on the concrete mix design, introduction about the mix design of the concrete, the definition and the other factors and the methods that we normally use for the concrete mix design. But before we start, this is a quick recap for the what we have taken in the previous session. We went through the introduction about concrete technology, what is concrete, what are the concrete ingredients, and the significance about concrete, why concrete is the most common used type of construction material rather than any other construction materials, and the application of the concrete in our life or in the construction industry. So back to the concrete mix design. Concrete, we can define concrete mix design in different way. So concrete mix design, it can be defined as the science of determining the relative proportions of the ingredient of concrete to achieve the desired properties in the most economical way. In other words, we can define also the concrete mix design as the process of finding the right proportions of cement, sand, and aggregate for concrete to achieve the target strength in the structure. So they are the same definition, and they are the same as we already know that the concrete contains of cement, water, and aggregates. And aggregates can be either fine aggregate, and also we have coarse aggregate. So this is the main ingredient to produce concrete. We need to have cement, water, and aggregates. An aggregate where we have fine aggregate and we have coarse aggregate. The fine aggregate is the sand, and the coarse aggregate is the gravel or stone or whatever you can call it. So the mix design here, in a simple words, that we need to know how much cement, how much water, and how much aggregate can we mix in order to achieve our target strength, So one of the advantages of the concrete, and what makes concrete different than any other type of construction materials, that concrete from the same ingredients here, from the same material, cement, water, and aggregate, we can design the concrete to a different strength, different compressive strength. We can design a concrete that has 30 megapascal compressive strength. 30 megapascal of compressive strength. We can also use the same ingredients here to design a concrete with 40 megapascal. We can also design the concrete with the same ingredient here to 45 megapascal. So whatever compressive strength you can design based on the same material. So the concrete mix design is a method or techniques that help you to know how much cement, how much water, and how much aggregate you can mix, or the ratios between these concrete ingredients in order to achieve your target compressive strength. So this is simply what do we mean by concrete mix design. So the concrete mix design, it helps us to know the ratio between the concrete ingredient, how much cement, how much water, how much aggregate, in order to get the compressive strength, your target compressive strength, in the most economical way. So we have many methods for or techniques that help us to determine the mixed proportion here, or the ratios, in order to achieve our target strength. And among different methods, we have Department of Environment, DOE, which is the British method that this course is about. But we have also ACI, the American Standard Method of Mixing Proportioning. We have road node number 4. We have trial and adjustment method, maximum density method, and etc. So we have so many methods that help us to determine the mixed proportion in order to achieve the concrete target strength. So among different methods, we will go with the Department of Environment's, the British method, DOE, which is stand of Department of Environment methods. DOE method here, which is stand of Department of Environment, and this method of concrete design was first introduced in 1950s under the name of Road Note number 4, and which was then later replaced by the design of normal concrete mixes in 1975 by the British Department of Environment. So this is why then it was published in 1975 and was then also revised in 1988 and often referred to as the British Standard Concrete Mix Design. So this is the most common British standard or the British method of concrete mix design. DOE method or Department of Environment method is applicable to concrete mixes for most purposes. You can use this method and it's actually the most common method that being used in terms of the how accurate is it and can be used to design a concrete up to 70 or 80 megapascal. DOE method helps to calculate the exact amount of material required to produce 1 cubic meter of concrete. So this method helps us to know how much cement, how much aggregate, and how much water we need to mix in order to produce 1 cubic meter. So if we have 1 cubic meter volume, how many kilogram of cement, how many kilogram of sand, and how many kilogram of aggregate, then you can get to know or determine based on your own volume. The principles of this method or this method of mixed design, the grade of concrete, grade 30, grade 40, grade 25, whatever target strength that you need, the characteristic strength and the standard deviation, the type of the cement, the types and the size of aggregate and their sources of supply, the maximum sizes of aggregate, the maximum and minimum cement content, etc. So what this is are the factors that is really affect the concrete mix design using this method. The type of cement, what type of cement are you using? What is the maximum size of the aggregate? The maximum size of the aggregate, is it 20 millimeter, 18, 16, 22 millimeter? So the maximum size of aggregates also help us to determine also the mixed proportion. And it's really affect the mixed proportion. The water to cement ratio, the degree of workability, how workable do you need the concrete? We have low, medium, and high workable concrete. And you need to have this information in front of you before even start doing the calculation process. Because you need to have the know what is the maximum size of the aggregate that is available and you want to use, what is the maximum and if there is any minimum cement contents, what is the maximum or the minimum density you want, what type of cement you want to use, and etc. So this information is part of the calculation and it's really affect the calculation, and at the end of the day we will come out with the mixed proportion. We will come and see how all this information, how we can use this information in the calculation sheet and in the calculation process later in the following session. Concrete mix design using Department of Environment methods, we will go through different stages and different steps. The first step by determining the target mix strength. The second one, we will determine the water to cement ratio for the mix. And step number 3, we'll start to determine the water contents. Then we'll start to determine the cement contents. Then determine the total aggregate contents. Then from this one, we can determine and calculate the fine aggregate or the sand contents. Then lastly, we will come out with the mixed proportion in terms of kilogram per cubic meter. This is the how many kilogram per cubic meter we need from cement, from sand, and from aggregate in order to achieve our target strength. So this is an introduction about the concrete mix design, the definition of concrete mix design. What do we mean by concrete mix design? And here is some information or some methods that we normally use for the that help us to determine the mixed proportion of the concrete. And among the five methods, we will go with Department of Environment, which is the most common use because it's accuracy actually. And DOE methods here, introduction about the and the principles and the factors that we need to check or we need to know of. This is information that we need to collect because these factors actually part of the calculation process. So we'll stop here and we'll see you in the following session.